graphs of the tangent and cotangent functions. So your objective is to graph the tangent cotangent functions given an equation. I do want to throw in there that A, B, C, and D are still going to do the exact same thing as they did on sine and cosine. So when graphing y equals tangent of x and y equals cotangent of x, we will have some vertical asymptotes. A vertical asymptote is a vertical line that the graph approaches but will not intersect, it will not cross it. It's kind of like a brick fence, you can't cross it. While function values increase or decrease without bound as x values get closer and closer to the line. So they're just going to get closer and closer to the line, but they'll never cross these lines. So let's look at tangent. So if we got y equals tangent of x, here they want you to make a table for each of the values from negative pi to pi. So we'll go, and if it's easier, start with the positive values and go to negative, but I'm going to go with negative. Negative pi, negative 3 pi over 4, negative 2 pi over 4, which is just pi over 2, negative pi over 4, and then 0. And then from there, we'll go into our positive values. Pi over 4, pi over 2, 3 pi over 4, and pi. Now this is where we have to remember our tangent values. Worst case scenario is you guys can go in there. You know tangent is 1 at pi over 4, and it's negative 1 at 3 pi over 4. We know tangent at pi is 0. Think of the airplane. At 0, it is 0. At negative pi, it's still 0. Now what we need to look at here is whether or not these are positive or negative. Negative pi over 4 is really quadrant 4, so it's negative. And this guy here is going to be positive. But here's what I want to point out is that pi over 2, whether it's positive or negative, tangent is undefined. Remember, tangent is the slope of a line. And if I was to look at this as being my grid, this is 90 up here, I have a vertical line. So here, this is going to be a vertical asymptote. This will be a vertical asymptote. And we can see that we're going to be graphing from negative pi over 2 to pi over 2. Now, I wish I had a unit circle I can throw up there, but I can always use this. Is if this is negative pi over 2, this is pi over 2, this gives us quadrant 1 and 4. We always want to graph from quadrant 1. And instead of going from, because this is an asymptote, we can't do quadrants 1 and 2. So we do quadrants 1 and 4 because 0 is not an asymptote for us. So how long is my period for this one? That's the question down here. What is the period for this function? The period for this function is going to be negative pi over 2 to pi over 2. So it's this bit here, negative pi over 2 to pi over 2, which gives us pi. Okay, so let's look at the second one. This is make a table. Again, we're going to make the table. We're looking at cotangent this time. So negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4, and pi. Now this is cotangent. Remember, cotangent's got reciprocal values, backwards values of, anyways, if you're looking at your chart, you have tangent, you go backwards for cotangent. But if this is pi over 2 again, and this is negative pi over 2, we're going to look at this as being 0 and this as being pi or negative pi, depending on direction. And cotangent, so again, negative 3 pi over 4, Same as tangent, it's going to be -1. Actually, this one was +1. This one's -1. This one's +1. This one is -1. The question is what's happening at 1/2 and, or pi/2 and pi. Tangent is 0 here, so cotangent is going to be undefined. Undefined there, undefined there, and undefined here. At pi/2 and -pi/2, cotangent is 0. So we have the question again is what is the period of the function? But what I want to point out is where it's undefined at. It's from here, it's undefined, to here. So we'll be graphing everything between, which is 0 to pi. So our period is pi. We're graphing these values for tangent. And from 0 to pi, that's our period for tangent. So, and the reason tangent has that restriction is because of the undefined values that it has. So let's graph a couple of these. So on this one here, to graph y equals a tangent of bx or y equals a cotangent of bx, b greater than 0, follow the steps, determine the period. And now the period normally is pi, so now it's pi/b. To locate your adjacent vertical asymptotes. So if you had something like this, you would throw the bx minus, I don't like that they're using c. You're not used to that being c. This is d, so we're going to change them. I'm going to change this guy too. I'm not sure if the book has that in there, and that's why they did that, but I don't want to confuse you guys. The d, this is a d value here. C would be something added on the outside. So they identify, the first thing you have to identify your vertical asymptotes. Sketch the two vertical asymptotes, and then divide your interval formed by vertical asymptotes into 4 equal parts. So you're going to put 3 dashes between your vertical asymptotes. We are not going to make a table. We're going to just use our ideas of what we know, and then join the points with this nice smooth curve. Okay. But again, if you want to make the table, knock yourself out. We are not going to do tables. Okay, so graph this over a 1 period interval. Y equals 2 cotangent of x. Let me put you on pause for now. Okay, so back to this one here. So our a value here, okay, do this again. Our a value here is 2. Our b value is 1. We don't have a c or a d. This gives us a period of pi. But remember, cotangent goes from 0 to pi. So if we don't have any kind of phase shift going on or shrinkage on the x values, then it's 0 to pi. So I'm going to put my value over here. Here's pi. And these are going to be vertical asymptotes. So I'm going to draw in some vertical asymptotes. One here. And I'll extend this one beyond it so that you guys can see that it's there. And there's the other one. Okay. So this is a bit that we're graphing. Our halfway point is going to be pi/2. And then we throw in our quarter points. Notice I have 1, 2, 3, 4 sections in here. Now the idea is how do we graph this? Because we didn't write a pattern down. But if we think about the airplane idea, we're only really concerned with some of our values. But for tangent, we're going to look at our pi/4, pi/2, and 3 pi/4. And at pi/4, tangent is 1. It doesn't matter, tangent, cotangent has the same values. At pi over 2, it is 0. That's the one they don't have in common. And 3 pi over 4 is going to be -1. Okay. But we have an a value, so we do have to take our a value and multiply by 2. Now, if you're going, wait, why do we do 5 with sine and cosine and tangent we're doing 3? Because the other two, it's a vertical asymptote, and then 1, 0, -1, vertical asymptote. We can't do anything with those vertical asymptotes. Multiplied by 2, it's still a vertical asymptote. There it is, vertical asymptote. 2, 0, -2, and vertical asymptote. There it is. So I put in my 1, 2 values here, my -1, -2 values down here. +2. And then we can graph these. So this is your pi over 4. So we come up, it's at 2. This guy's at 0. This guy is at -2. This is when I get to throw out there, even though this looks linear, it is nowhere near linear. Your graph comes down and it curves over and then it goes down across that way. This is what the cotangent graph looks like. It goes left to right, up, and then goes down. And that's all there is to this one here. So I'll try to make sure that we're pointing things out, that these are the values that we normally would graph if there's not shifting back and forth. But I don't want, I'm using this to identify where the 1, the 0, and the -1 came from. Okay, next one. Okay, they gave you tangent this time. Again, 1 period interval. A equals 3 and B equals 1/2. So our period would be pi over 1 divided by 1/2. So times 2 over 1 times 2 over 1. Again, I made this a fraction because my b value is a fraction. Those cancel out and we're left with 2 pi. So instead of pi, we are going to do 2 pi. And we'll do the inequality to keep you guys in there so you're not going, well, where do I start, where do I stop? Because tangent does not start or stop at 0. So normally it's at -pi over 2. And then the 1/2 of x, 1/2 x, less than or equal to pi over 2. That's where our graph normally is. So to get rid of the fraction 2 here, I'm going to multiply by 2, multiply by 2 over 1, multiply by 2 over 1. So over here I get -pi less than or equal to x, which is less than or equal to, and my 2's cancel out there, pi. So we can put it in there going, this is pi, this is pi. Those are your vertical asymptotes. Anytime you get the beginning and end of these, they are your vertical asymptotes. So there's one and there's the other. I'll scooch that one over where it's supposed to be. Okay. I don't know if it's just me or if it looks crooked. I think it looks crooked. There, much better. So there's our vertical asymptotes. Beginning, end. 0 is going to be our midway point, and so we just need to throw in the quarter points. There's our quarter points. Now, these are normally going to be at pi over 2, -pi over 4, 0. I'm just doing this to get our points in there. Okay, this is going to be in my way. We'll come down a little bit. Okay, normally, there we go. Normally, we would do pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Now remember, we're talking about tangent this time. And tangent at 0 is 0. When tangent at pi over 4 is 1, at negative pi over 4, it's negative 1. Remember, we're in quadrant 4 down here. And this guy is undefined, so we get a vertical asymptote. This guy is undefined, so we get a vertical asymptote. And we get to go through and multiply all of our values by 3. So really, our points, we're going to graph vertical asymptote, -3, 0, +3, vertical asymptote. So there's 1, there's 2, there's 3, there's 1, there's 2, there's 3. So at this point here, it's going to be, I believe it's going to be -3, -3, 0, and then here it's going to be up to +3. And now I could extend my asymptotes to go up higher, but the point here is that this guy comes down, comes across, and then starts heading down again. Okay, I missed my points. But this is what the graph is going to be doing. I can also cheat and get them to make it work. But notice cotangent came from the left and went right, and tangent comes from the left and goes down. Okay, let's try another one. Okay, this one has a little bit more going on. It's cotangent. Cotangent normally goes 0 to pi. Our A value is 1. Our B value is 2. So our period is pi over 2. Our C value, we don't have one, and our D value is not the 3 pi over 2. We have to account for this guy here. It is actually going to be 3 pi over 4. So we can still verify this thing. So remember, cotangent normally goes from 0 to pi. Now, because we have a fraction here and another fraction here, and we're going to add and subtract this guy, I'm going to go ahead and change it to degrees so that it's easier for you to play with. So I have 0 is less than or equal to 2x minus 270, which is less than or equal to 180. Add 270 everywhere. And I will point out, if you're looking at what we're doing, I identified my A, B, C, D values and my period. But the very first step tells you to find your asymptotes, and that's what I'm doing now. I haven't touched the graph because I can't until I know where I'm starting and stopping. So 270 is less than or equal to 2x, which is less than or equal to, this is 450. Divide everything by 2. And half of 270 is 135, is less than or equal to x, which is less than or equal to half of 450, is 225. So if you're looking at the unit circle, you're going from halfway of the unit of quadrant 2 to halfway through quadrant 3. So I need to put these values on there. Oh, this is 3 pi over 4 to 5 pi over 4. That's the area I'm graphing. Now this asks you to do it over a 2-period interval, so we've got to talk about that guy too. So since my end and beginning points are pi over 4s, I'm going to just, everything I'm going to put in there is going to be pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. I think that's where we're stopping. Yes. So my 3 pi over 4 and my 5 pi over 4 are vertical asymptotes. Okay, and I'll fix those here. Move this guy over where he belongs. Those are my vertical asymptotes. Now notice on this one, every 90 degrees, and since these are pi's over 4 and they say to do a 2-period interval, we got it kind of set up. But I'm going to do the one and then we'll go to the other. This is cotangent. Remember, cotangent has this shape. So all we have to worry about is the a value at this point. A value is 1. Here's 1. There's -1. So at this quarter point, I would be at 1, 0, and at this quarter point, I would be down at -1. This graph just is going to look a lot more squeezed in there is what it's going to do. Now, that 2-period interval, you can extend it this way or you can extend it back this way. Since I already have this here, I'm going to do this one in a different color so that we can see the 2 different ones. But since we already have this here, this is 90 degrees, and from here to here is another 90 degrees because it's pi over 4 to 3 pi over 4. So this would be my other asymptote, and hopefully you can see going, yep, I have one little mark in between. And then my halfway point and my halfway point. And the graph is going to look the same. Up to 1, 0, down to -1, and the graph is just going to continue repeating itself. Okay, that should be more of a straight line. But the graph is just going to continue down and repeat itself. If it's too, I just have to identify the fact that all you're doing is continuously repeating what you've already done. So the first one is the blue one is the one that they're asking you to do, but tangent and cotangent both just continuously repeat themselves every 90 degrees, or in this case, actually this was 90 degrees, normally every 180 degrees, but this one kind of got squeezed in. Okay, I believe we have one more. I know that we're pushing on the time, but I'm going to hit that last one because this guy's got everything going for us. Again, a 2-period interval. A equals 3, B equals 4. So our period is going to be pi over 4. This is going to be a very small graph. My C value is -2, and my D value is -pi over 4. Now we can, again, double check this one here. This is just telling me that I'm going to move it to the left, pi over 4. So let's go through this. Tangent normally starts at -pi over 2 for x plus pi is less than or equal to pi over 2. Again, we have fractions and such, so we're going to change this to degrees. -90 is less than or equal to 4x plus 180, which is less than or equal to +90. Okay, so the first thing we're going to do is subtract 180, minus 180, minus 180, minus 180. I'm going to just bring this over here. So I get -270 degrees is less than or equal to 4x, which is less than or equal to -90. So we already know that we've moved it all the way over this way. And now we're going to divide by 4. This gives me -270 divided by 4 gives me 67.5 degrees, which is less than or equal to x, which is less than or equal to 90 divided by 4 is going to give me -22.5. Yes, this guy should be negative as well. Put this back into radians. We're going from -3 pi over 8 is less than or equal to x, which is less than or equal to pi over 8. Okay, so we moved the graph quite a bit, plus did a lot more. So I don't want you panicking over this one, but I can prove that the period on this thing is pi over 4, because with pi over 4, what we did is if you take the negative, this is negative as well, negative 3 plus, no, that's not one. I did this one earlier. I'm gonna pause. Okay, so on this one here, if we were to add these two together, I'm sorry, subtract these from each other, the beginning from the end, negative 3 plus, actually it's negative pi minus the negative 3, so plus, will give you 2 pi over 8, and 2 pi over 8 is pi over 4. So we know we have our period correct, and with our d value, that showed us how much we're moving it over. Also, if you want to verify that d value, you just take the 4x plus pi and set it equal to 0. So you get 4x is equal to negative pi, so x would be equal to negative pi over 4. And that's where this value up here came from. Okay, so now we have to graph this thing. And it even tells us to do it over 2 intervals. So I'm going to purposely make these really wide so we can get them in there. I'm going to claim this to be negative pi over 8. So this would be 2 pi over 8, and this one would be 3 pi over 8. Yes, I know, they're supposed to be negative. We need our vertical asymptotes, so if I pull down our vertical asymptotes, we have our vertical asymptotes. This is tangent. Oh, but we have our A value and our C value we have to identify. So if you remember, tangent goes vertical asymptote 1, 0, negative 1. I lied, it goes it. No. That's cotangent. Yeah, it goes the other way. Negative 1, 0, 1, because we're starting in quadrant 4. Negative 0 goes positive. But we have to multiply these babies by 3, and which gives us negative 3, 0, positive 3, and then we have to take the C value and subtract 2 from each of them. So negative 5, negative 2, and then 1. So at this point here, so I know I have to go down to negative 5. 1, 2, 3, 4, 5. So that point here goes here. My point in the middle, this guy right here in the middle, is going to go down to negative 2. And my other point is going to be at 1. So what's happened is that we're up against the asymptote, and then it curves down and then comes back down this way. Now, it did tell you to do it over a 2-period interval. So you can go either way. I'm going to go to the right. I have negative pi over 8. This will be 0 pi over 8. And then this will make it positive pi over 8. Notice that we just did 1, 2, 1, 2, 3. This would be 1, 2, 3. So my other vertical asymptote goes here. And then I get to cheat. You guys unfortunately cannot. I get to cheat, and I can clone this thing to bring my graph over where it's supposed to be. And then we get the duplicated graph. I know there's a lot going on in here, and I know this video is kind of long, but I did not want to, I can't do 2 videos on just a few examples. And I'm going to throw the homework up here, but I'm going to put out there that we're going to do something different with the homework, but we will be looking at these problems. Good luck.